Okay, hello everyone. My name is Damien, and this is my first time on Warsaw JS. First time as a presenter, and first time as a member. It didn't take me long to get here because I have an office on the second floor on this building. So it was really easy to get here. And today we're going to talk about the front-end Web 3.0. This topic is maybe a little bit mysterious, but it was challenging for me to present it in such a short period of time. But I hope we're gonna make it. I'm working as a front-end developer for more than 5 years, and I started working in a corporation for 3 years, then in banking for 1 year, and last 2 years I've been working on startups, on blockchain startups. And currently I'm working on Woo Network, which is the fintech startup that have liquidity pool and exchange for professional traders and decentralized exchange also. And today we're gonna talk about, we're gonna understand what the blockchain is. We're gonna compare Web 2 and Web 3, about the architecture of decentralized applications, and smart contracts at the end, coding. But coding is like overstatement because I'll be mostly showing you code. Okay, so the question for you guys. Everyone probably heard about blockchain. Who heard about blockchain? Many of you. Who understand blockchain? Oh, plenty of people. That's great. So the first part, I would like to present to you what the blockchain is. And I prepared this. I have this demo prepared by someone else, but explains really well what the blockchain is. So first of all, we have to understand what the hash is. So hash is a fixed string with a fixed length. And hash is generated by the hashing algorithm, and based on the data we input, the hash changes every time. Okay. So now, as we know what the hash is, let's move to the block. So block is a wider explanation what the hash is. We have also a hash, but now we have 3 inputs data. We have block, we have nonce, and data. So data is the same as before, and we have another input which is block number, and nonce, I will explain a little bit what does it mean. So in this example, we see that this hash starts with 4 zeros. And this is very important because when we change this data, we see that the hash changed to the start with 8043. So we are missing these 4 zeros, and we want those 4 zeros because right now, like you see, this block is red, so it's not valid. So in order to make it valid, we have to mine it. So mining basically is just find this nonce, this number that's gonna generate our hash that starts with 4 zeros. And mining is probably, you guys heard, it was like very popular when people were buying graphic cards to PC to mine blockchain. It was a trend, and this is basically in like really simple concept what the mining is. So someone is using the computing power to find the hash that's gonna validate the block. So now we know what the block is, we can move to the blockchain. So blockchain, as a name suggests, is a chain of blocks. So in this example, we have 5 blocks, and they have another input, which is previous hash. So this block number 5 pointing to the hash of block number 4. And when we change the data here, we now see that this block is not valid. So in order to make it valid, we have to use the computing power to make it valid again. But what's going to happen when we change the 4th block? Now we see that we generate a new hash on 4th block, and we the block 5 pointing to this block 4. So those 2 blocks are not valid. So we have to use even more computing power to validate those blocks. And that is why it's so powerful to manipulate the data in a blockchain, because when we go back to the past, the more we go back, the more computing power we need. But the true power of blockchain is his distributed nature. And like we see here, we have also the blockchain, but we have 3 copies of blockchain, pure A, B, and C. And basically, it means that when someone, for example, want to manipulate the data in a blockchain, and blockchain is a big database, like public data, decentralized database. So if someone change it and mine it, for example, because he's the owner of this blockchain, we see that something is not going, like on the first, everything is fine. But when we compare this hash of the first block start with 4CA, and next one is 4B9, and the next one is 4B9. So those two blockchains are like, okay, something is wrong with the first one because it has different hash for the same block. So in a blockchain, it's like a democracy. So in this case, when there's more than 50% of blockchain with the same hash, the other is just invalid. And that is why it's like almost impossible to manipulate it. And on the most popular blockchain, which is Ethereum, there are right now around 7,000 of nodes. So like the copies of blockchain spread around the globe. So someone would have to be capable to own more than 3,500 nodes to manipulate the data. So that's why we love the blockchain. Now we can explain what a Web3 is. So we had a Web1. It was like read-only. So we were just like reading content. And then we moved to Web2. So it's what we are living right now. Social media was a very big part of Web2. And now we can read and write data, but this data doesn't belong to us. And this is what Web3 introduced, which is like read, write, and owning the data. So user, like I'm owning my data, and no one has access to my personal data. And but there are also like limitations to it. But that's the big part of Web3. So benefits and limitations. So first of all, main benefits that the Web3 is open to everyone. Web3 is open to everyone, and like for example, Facebook right now can delete the post, can block the account, delete the account, and in blockchain this is impossible because no one owns the data. Security, we have payments built in with a native token, so it's already secure, and this transfer doesn't require any personal data. And zero downtime, because it's decentralized, so it's like impossible that it will go down. But we have also limitations, and the big limitation is scalability. The transactions are much slower because, like I mentioned, like I showed you before, it requires computing power. Every time, every transaction requires someone to mine it, to validate those blocks. We have a security, but there's also a cost. Like the second one, so cost is when we put the code into the blockchain, we have to pay it. Any program, any data, every time we write something, we have to pay it. Only read access is free. And the most interesting part, like for me, is UX. So interacting with Web3, because this is on my side as a front-end developer, we can make the Web3 more popular and easy to access, because right now for the like standard user, it might be a little bit difficult to use it. Okay, so now, like brief comparison of the Web 2 and Web 0 based on the architecture. So on the left we have architecture of the Web 2. This is, we all know, like front and back and a database. And on the right is decentralized application architecture. We have front end, and we have Ethereum, a blockchain. And the main part is Ethereum virtual machine, which is a platform for building the decentralized applications. And on this platform, we are running programs. And those programs are called the smart contracts. As I show you as an example, to compare like real Web 2 and Web 3, let's look at the example. We have a exchange which is Web 2, like Web 2 application. So here, when you register, you have to put your personal data, email, and this data doesn't belong to you. And we also have the centralized exchange. And here we are using only our profile, which is already created, and there's no personal data. There's like only a string, our address. We have a address which looks like this. So it's like almost random string, and this is how the Web3 application validate this is us. And I will show you later the example. Okay, so like I mentioned about smart contracts, the most popular blockchain is Ethereum, and Ethereum using their own language, which is Solidity. And Solidity is like, I would say, is a combination of C++, JavaScript, and Python. It's objective language, and in Solidity we can write smart contracts, which are the blockchain applications. And yeah, let's go. Let's try to show you something like real example. I hope you guys see it. Maybe we'll make it a little bit, yeah, zoom in. So what I'm showing right now, it's Remix IDE. It's Ethereum IDE that you can write smart contracts on a browser. You don't need like your own IDE, but you can use it. Of course, we can use it. We can do it in Visual Studio Code also, but it's very useful. So right now, for the purpose of this presentation, I prepared like really simple application. It's like, we can say it's a backend for our front end. In Solidity, we go through it very quickly. We always make sure that we have a correct version. We start with word contract, and we put the contract name. And here we are going to store a programmer, so with properties name and age. Then we have a mapping, so it's like a storage of key value pairs, and a function which looks like almost like in JavaScript. We're going to store a programmer, we're gonna pass name and age. And here we declare this function is public, so anyone can use it as long as he knows the contract address. And then we create the programmer and push it to programmers key value pairs. And then the next function, we need to get some data to show it. So we're gonna get the programmer age based. It's also a public that returns an age, and that's all. So okay, it's very simple application. So what we're gonna do right now, we have to compile. The Solidity language has a file that has Sol extension. When we see compile, it's compiled, there's no errors. Then we use this button to deploy the smart contract to Ethereum test network. And we see right now that on the right, we have in our browser, in Chrome browser, we have an extension, which is MetaMask. It's our wallet. It helps us interact with blockchain environment. It's the most popular way to interact with blockchain. And right now, it tells us that we have to pay this amount of this native token to deploy this backend to the blockchain. And we click confirm, and we can check the status. It's going to take some time to validate the block on Ethereum test network. On a production, it takes much longer, but on test network, usually it's a couple seconds. And yeah, we have information that the contract is deployed. And when the contract is deployed, we can see him here. And we see that we have those methods we can use to interact with smart contracts. And we have this address we can copy of the smart contracts. And one important thing is that we also have something called ABI. ABI is like, I'm always laughing that it's like API because it's like this contract description. And we need this to tell our JavaScript application that in smart contracts, we have those methods and how we can use it. But it's gonna, I just want to mention it, but we will see it in a second. Okay, so now we have deployed the smart contract. So we have a, I would say, backend ready on a blockchain platform. So let's move to the front-end part. I prepared like really simple application. I'm not even calling this application, but I'm just a demo, I would say. And we're gonna connect with the blockchain. We're gonna add a couple of the programmers to the blockchain. So we're just gonna store the data. And then we're gonna display here age for the programmer with the specific name. Okay, so first of all, we have our IDE here. First of all, when we create React application, we need one thing. We need Web3 library. We have installed the Web3 here. So Web3 is like one of the most popular libraries to connect with smart contracts from the front-end part. There are also other libraries like Ethers, but this one is like the oldest one and has the biggest community. So when we have this library installed, we create the instance of this library. So we just like import it, and we're gonna pass as a parameter, we're gonna pass the provider. How are we gonna get this provider? When we install this MetaMask plugin to our browser, we see that we on a window object, we have Ethereum object. And this Ethereum object has some properties, and we can use it, and we can pass it to Web3 library, and then the Web3 will know that we want to connect with smart contracts using the MetaMask. So when we have the instance of it, then we're gonna import it. We have instance, so Web3, we already have it. What we need contract address. We can get it from here. I copy and paste it. Yeah, we have a contract address. Like I mentioned before, we need this ABI. After compiling the smart contracts, we have something like ABI. I will show you how it looks like. So this ABI is like a contract schema, that it's a description of our smart contracts. So using this, Web3 can knows how to interact with smart contract. So we also import this ABI, and to create a contract that we can do something in our application, the contract object, we just create new instance of Web3. We pass this ABI, so description of the contract and contract address. And now under the contract, we can use the contract methods. So let's use it. Okay. So first of all, we want to display in our application. In our application, we want to display this our account number. So in order to do it, we just gonna use the Web3 and get. We are right now not interacting with the smart contracts. We're just interacting with the our MetaMask, and we're gonna save this. We're gonna store it. Okay. So right now, when I click connect, it asks us that this application wants to connect. We just click approve it, and then we see our address. That this is, when we go here, this is the same address I got here. So I'm connected to the blockchain tested network, and this is my account. And I just want to show you guys that we can display it here. Okay, so let's make it. Oh, 1 second. It's like difficult to operate with one hand. Okay. Let's make sure that we're gonna display every time. So I use the use effect. So you're gonna have this account always visible. Okay. So next, we wanna. Right now we have form, name, and age. So we want to add the programmer to the blockchain. So we have a function here, submit programmer. That's run on click on form button. So we can use await. We have a contract object, and contract has methods, and one of this method, like we have here, is store programmer. So we're gonna call this method store programmer. And like we see here, we have to pass name and age. So we have name and age. And in order to call this method to tell the Web3 that we want to store some data, we are using method send. And this method requires one parameter at least. We have to tell from whom we are sending this. And we're going to send this from our account. Okay, I hope it's going to work. Okay. So let's say we create Damien, and he's like 29. So right now, we see that we have a contract interaction, and we have to pay this amount of Ether to store this data in a blockchain. So we just click confirm. We can check the status here. Yeah, it's saved. And let's create another programmer. Let's start Anna also. And it's pending. The blocks are validating. And yeah, we store it. Okay, so now we have to make sure that this data is really stored in a blockchain. So let's display it. We have this function that if you pass name, we're gonna see what's the age of the current programmer. So we're gonna get the data. Okay, so let's type age, and we also going to use the contract method. Contract methods, and the contract method we had was get programmer age. We pass the programmer age, the programmer name, and when we want to get the data, we use different function. We use it call. Okay, and then let's store this age. Okay, so now let's type Damien, submit, and like we see, the data is in a blockchain, and we can type Anna. Anna was, I think, 19. Yes. So this data, like we see, there's no pop-up from the MetaMask because like we are getting this for free. We don't have to pay it. Read access is free. And we deploy the contract. We just get the data from the contract. And like you see, it's not that, it wasn't that difficult. So thank you very much, guys. I know it was hopefully it worked. So that's great. And if you guys have any question, I'll be happy to answer.
1, 2, 3, 4 questions, 5 questions.
Thanks a lot. Great demo, by the way. I have a question about the Web3.js library, because right now we have over 10,000 different tokens and cryptocurrencies. Does this is this the one library to rule them all, or for each, for example, for each token we need to use the different library?
Like right now, like I said, there are two main ones, and it's Ethers and and Web3. And basically, at my job, I work in different projects on creating DEXs when we swap different thing on Binance Exchange, on Ethereum, and everywhere we use Web3, and it was enough. And I know that there are different networks that are getting more and more popular.
Yeah, like Solana or Matic, they are different networks. So this Web3.js is also work with them, or they should have some different library for that?
Actually, I never use the Web3 with different chains, like Solana or Matic. I've always used with chains that are based on Ethereum network. But that's a good question to look at it and figure it out, which one would be the best.
Okay, thanks.
All right. So there are also two questions from YouTube. So question, what problems does Web 3.0 solve and for whom? What are the new capabilities generated to users over Web 2.0 apart from paying for every write operation?
That's a good question. So I don't know. This is actually the question about the value of the privacy. That's the main question, not the only one. But for me, for example, the great part is that everything what I do is not going to be like tracked, and my data, especially my personal data, are only for me. And whatever I do, it's only I know that I'm doing it, unless someone knows my address and can check whatever I'm doing. But basically, I think it's not gonna be like used everywhere, because Web 2 is gonna stay with us. Like for example, I know that there are right now people are working on social media on Web3. There are even some that are working. There's a YouTube on Web3 already working. You can Google it. And the great part about it is the community. They all want to create something that's like based on a privacy. And the other part is like working together, because we have like a concept of decentralized autonomous organization, DAO, and this is like really interesting concept that everyone can be paid for, not for like a work, but they're gonna be paid for playing games, for learning, for doing stuff that we are not paid normally. And this is what blockchain brings. This is like really early stage, but I think it's gonna bring the society on the next level in this case. But I really recommend to check this decentralized autonomous organization, DAO. This is like really interesting concept.
All right, amazing. So the last question from the room.
So my question is about like computer power we need to do such like even simple operation. Like, is it much more than doing it right now? Like, wouldn't it be the case if like lots of people start using this like blockchain? Wouldn't it be the problem with the computer power?
You're talking about like you as a user?
Like on the global
Okay, so like you as a user, don't need like a computing power to interact with smart contracts, because everything, all the computation and everything is running on those blockchain nodes. But the part about the popularity is that the more people use it, the more transactions and the more data will go through the pipeline. And then, for sure, we need more computing power. But people are working with different chains that are more, the scalability of those chains is different than, for example, in Ethereum. So the fees are lower, and you can, for example, in Ethereum block, you can pass the fixed amount of transactions. And let's say we have like 300 megabytes of transaction, or let's say like 1,000 of transaction. But we have right now have blockchains that are they can pass like 1 million transactions per second, and we introduce different algorithms and different ways to optimize this, and I think the problem still is, and we still have problem with the scaling of the network, but I see that with every like month is getting the blockchain is getting faster and faster, and there are new ways to speed it up.
What an amazing presentation. Thank you very much, Damian.